Say you want to find the escape velocity of a rocket, right? It has some initial total energy, which is equal to P equal initial, right? And then it has some final total energy, which is equal to P equal final, right? Now it's trying to break free of the planet's gravity, so we have kinetic energy, right? Now, normally you would use MGH here, but this only works for the surface of the planet, and we're trying to, break free of that, so we would use negative G M M over R plus half MV squared. Call that R initial. Then we have negative G M M over R F, right? Now, let's say this distance here is R, and let's say this distance here is, well, we'll just call it little r for right now. This is the radius of the Earth, okay? So then this turns into negative G M M over big R. This turns into negative G M M over a little r plus half mv squared, right? Okay, now since, let's pull that back a bit. There we go. Since this is the total energy at two different times, you can set this equation equal to this equation due to the conservation of energy, right? Because again, this is just the total energy at some initial time and then at some later time. Now, if the energy is conserved, which it should be, then that means you can set these equations equal to each other, right? So then we have negative G M M over R plus half mv squared equals negative G M M over R, right? Now, let's say that R is way bigger than little r, right? Like right here, you can see for yourself the distance the rocket is traveling to is way greater than the radius of the Earth, right? So let's say that R is approximately infinity because of how big the difference is, right? So then that means this goes to 0. So now we have half mv squared minus G M M over R equals 0, right? Or half mv squared equals G M, I can learn to write. Yeah, alright. So now everything looks simpler. So then you have v squared equals 2gm over r, or v equals the square root of g m over r, okay? And as you can see, it doesn't really depend on the mass of the object, just the mass of the planet and the radius of the planet.